Now we have a rule for what happens when we mix addition and multiplication. Do we have a similar rule for what happens when we mix multiplication and exponents? Say we have two numbers that we're multiplying together. 2 times 3. And we want to raise that product to the fourth power. Now I could just do this multiplication and then raise this number 6 to the fourth power. But I'm not going to do that because I want to look at what happens. Right, I'll have 2 times 3 times another copy of 2 times 3 times another copy of 2 times 3 times yet another copy of 2 times 3. Right, I have 4 copies of the expression in parentheses. But multiplication is associative, so I can just drop all those parentheses. And multiplication is also commutative, so I can rearrange this so that all the 2's come first, followed by all the 3's. So I've got 4 copies of 2, and I've got 4 copies of 3. So this is 2 to the fourth times 3 to the fourth. I want to confirm that that worked. I want to confirm that 6 to the fourth really does equal 2 to the fourth times 3 to the fourth. So I'm going to go to my calculator and I'm going to work out 6 to the fourth is 1296. 2 to the fourth is 16. 3 to the fourth is 81. And now I'm going to multiply 16 times 81, and I do get 1296. We can state this more generally in terms of equivalent expressions. If we have real numbers x and y and an integer n, then multiplying x times y and then taking the nth power is the same as taking the nth power of x and the nth power of y and then multiplying them together. And the same pattern as we saw up here still applies, right? If we have xy to the n, that's going to be xy multiplied by itself repeatedly. There'll be n copies. We can rearrange that to put all the x's first, followed by all the y's, and we have n copies of each. And so that works out to be x to the n times y to the n, just the way we thought it would.